My name is David Smith. I'm an Extension Program Specialist with the Texas A&M Agrilife Extension Service in the Department of Biological and Agricultural Engineering. In the last few years, you've likely heard the term greenhouse gas in the media in the context of climate. So today I'm going to talk a little bit about greenhouse gases and how they relate to agriculture. So the term greenhouse gas refers to those gases that occur naturally, or there's some are synthetic, but they have the ability to absorb and emit thermal radiation, or what we call heat. So among these gases are water vapor, carbon dioxide, methane, nitrous oxide, and ozone. So without these gases in our atmosphere, the average global temperature would be around 0 degrees Fahrenheit. So with these gases, our average global temperature is actually around 60 degrees Fahrenheit. So while most of these gases occur naturally, there's an ongoing concern that human activities are increasing their overall concentration in the atmosphere, which is leading to a rise in the average global temperature. So while most of these anthropogenic or human-caused greenhouse gases are due to industrial processes in transportation, scientists believe that around 8 to 10% of greenhouse gas emissions originate from agriculture. So these include, enteric fermentation from livestock, or animal manure management, rice cultivation, and fertilizer and soil management. So in agriculture, the two most prominent greenhouse gases are methane and nitrous oxide. So roughly 70% of agricultural methane comes from ruminant enteric fermentation. So during the digestion process in ruminants, they break down food and release methane as a byproduct. So most nitrous oxide emissions in agriculture occur or they're released from soils after the application of synthetic and organic fertilizers. So there are many ways that agriculture can reduce their greenhouse gas emissions. And in fact, many of these same strategies are good for the bottom line. So for example, in beef cattle production, this means improving the fertility rates or calving rates, increasing feed conversion efficiency, or improving weight gain. Also, there's a lot of research that's going on that is looking at how to improve the digestibility of feed to reduce the methane during enteric fermentation. So for dairy operations, this might mean higher milk production, requiring less cows, or implementing manure management strategies that actually capture methane from manure and use that as a fuel source on the farm. And then in livestock and poultry operations, proper storage, treatment, and application of manure is really key. So for example, doing composting the manure, or covering the manure and capturing the methane gas to use as a fuel source, or subsurface application of manure to farmland. These things can reduce methane and nitrous oxide emissions as well. So as I mentioned earlier, many things that producers are already doing to make their operations more profitable and sustainable are also things that reduce waste and the associated greenhouse gas emissions.